Good afternoon, everybody, and welcome to this month's AGU Heads and Chairs webinar. I'd like to make a few introductions. First is Pranoti Asher, who is Manager of Higher Education at AGU and also AGI Scholar in Residence. And myself, Christopher Keene, I'm Director of Geoscience Profession Higher Education here at AGI. Leila Gonzalez, also with AGI, is helping us out as well through this webinar. And without further ado, I'm going to go ahead and get started with our the presentation today. This month, we're taking a look at the current trends in the geoscience workforce based off of data and activities that we have been doing here at AGI, both in some direct surveys as well as looking at federal data and talking with employers out in the community. For today's session, I'm going to hit really three primary areas. The first is a fairly brief data snapshot of where things are within the workforce today. Another section looking at general feedback from employers as we've had, go out and we talk with them and try to understand what the current hiring environment looks like for geoscientists. And then I want to tap a number of macro issues that are emerging that I think are very important that geoscience programs need to be aware of. Hopefully most of you are cognizant of them, but I think for completeness, we want to make sure people have a strategic outlook of things that might impact your programs and also loop back to the employer space. So in the data snapshot area, one of the the key things we always show is our enrollments and our degrees granted graph. So this is the enrollment time series through 2018. I'd like to place a shout out to all the departments. We've got about 400 departments already have updated their enrollments for 2019, and we'll be having that data out in a couple months. But through 2018, we see this continued long-term rise in undergraduate participation, which is good. And our graduate enrollments remain fairly steady, and that largely has been identified as most of our graduate programs are running at capacity. One of the things, though, that it has shown up, and we're trying to find a way to accurately divine these numbers, is on the undergraduate side, we have a growing number of students who are in online-only programs. We have quite a few now that have arisen. Both more traditional geoscience programs as well as geoscience education programs at the undergraduate level. And this seems to be accommodating for a decrease that is occurring on campus in traditional students. The last sort of number that we were able to get our hands on was we had about 5,000 majors that were in dedicated online programs. When we look at degrees awarded, as one would expect, has a lag time and is a bit of a muted response to those enrollment curves. And as would be expected, the bachelor's degrees continue to increase over the long-term trend. Been a few little adjustments here and there, usually for some specific macro events. But I want to point out our graduate degrees granted, we're starting to see a bit of a recovery at the doctoral level. Had been sort of suppressed ever so slightly for a while. But then also 2012, just point out that step function, we saw a 47% increase that ended up being structural in the number of master's degrees granted. And working with the departments, what came out was they were seeing a strong shift of folks that were in graduate school deciding to exit at the master's so that they could go out and get jobs in the booming economy from shale gas that was driving so much of our employment, whether it was on the actual energy side or in the environmental side. And this had suppressed a number of the doctoral students in the doctoral programs going to completion. And I think what we're seeing is as the economy, and particularly in the shale gas area, has softened, we're seeing a bit more of a return back to normal long-term trends. So when we look at our exit survey and we look at first destination employment of bachelor's recipients of geoscience degrees in the United States, through 2017, You can see some trends. You can see the decline in hiring in the oil and gas sector. This again is very much in the whole shale gas space. They were hiring anyone and everyone. They needed folks on the rigs out in the field, and which was not normal for the long term in the oil and gas industry to have so many people employed at the bachelor's level. And so we're getting back down to sort of the normal space where the energy sector is not really a major employer of folks with just coming out with a bachelor's. The environmental services sector has continued to grow. A lot of that growth is actually driven on the shale gas. They're not worried about the exploration, but as production continues and field retirement occurs, their business continues to boom. Mining continues at a very steady state, and this will be a sort of an ongoing theme through a lot of this discussion. And you see this dramatic increase in the orange of the federal employment. These are largely bachelors in geoscience being hired on as technicians in federal agencies. There was a lot of hiring at the end of the Vietnam War. A lot of Vietnam vets ended up going into the federal government and were taking on technician jobs. Most of them have basically been retiring at the same time. And so talking with folks in the federal agencies, this is a big chunk of that replacement. So they're hiring our bachelors for those kinds of positions. If we move up to the master's degree, which is still considered, and we have some pretty good data later that shows is the degree of optimal employment in the geosciences, you can see oil and gas continues to be a major player. Maybe not as much as it was during the real boom times, as you can see when they were consuming about 75% of our master's recipients. Again, you can see mining, which is this dark green, continuing pretty steady state, and largely because there's a constrained supply, out of here in the United States, but there's a steady replacement required. The environmental services continue to be a good player in this area, but you see the growth in the federal government. And again, talking with folks at federal agencies, what we're hearing, these are basically replacing the retiring GS 10, 11, 12 kinds of positions, that are at places like USGS and DOE and other similar agencies. And then when we move up to the doctoral level, you see really the dark blue at top being research institutes, and down here the four-year universities. A large proportion of those are actually postdocs within that space, plus folks that are getting permanent positions, but certainly sort of what I would say the traditional pathway for most are PhDs. The oil and gas sector is continuing to hire. This is a more normal rate of hiring of PhDs in the energy sector over the long term. But I think as you can see that there's been a decrease in federal hiring at this level, and largely that's a contraction, not nearly as much. There's hiring freezes and other processes that are slowing down the hiring of folks at the more senior GS levels, particularly coming in out of school. And so we talk about the projections on employment, and so this is built from Bureau of Labor Statistics data. And when we look at the next 10 years, the total number of geoscience positions available in the United States are expected to grow about 6.2%. This is almost dead on what the expected economic growth is of the country over that time. So as a percentage of the economy, it's pretty steady. There's reason to view these numbers as being fairly reliable. If you think back to a number of years, if you saw some of these presentations a number of years ago, you'll see that that's dropped. It was up in the 9% level, and a lot of that, projected heavy growth has actually been substituted by things like machine learning and automation, making geoscientists more efficient. So the actual number of individuals has decreased a little bit. If you look here across the area, sort of the senior, sort of the manager kinds of spaces is not nearly as robust in growth. And sort of the workaday scientists, the geoscientists and the hydrologists and the civil engineers are running right about what the expected growth is. So you can sort of consider it flat to the economy, but certainly still good prospects for students coming out of school. But what you can see here is, again, a lot of demand over and growth in the technician area. as we become more data centric and data demand. It's ironic. We hear a lot of employers say scientists make terrible technicians. They don't tend to be as detailed oriented. And so you're seeing some of this kind of play out. And again, environmental scientists, what that exactly means is a little challenging because there's a split between physical and biological sciences, but interesting to see atmospheric, soil. These are applied areas in the economy at this point, and so we're seeing pretty good growth. Now, if we look at those same changes but apply it by industry, there's a couple things I think that are particularly interesting. One, obviously, this huge growth expected in finance. Obviously, a lot of that is because it's starting from a relatively low end. But the reality is that the finance sector has always been a steady consumer of geoscience graduates, usually in the single-digit percentage areas, but has continued to be an area and it's expected to grow. The support activities from mining at 20% growth is interesting because in their terminology, mining also includes oil and gas production, and that's offsetting what we're seeing is drops in employment in mining and oil and gas extraction. And so what you're really seeing is a systemic trend that groups like BHP and McMoran or Chevron or Exxon are hiring fewer and fewer geoscientists directly, but rather they're using them through the service providers, say like Schlumberger. So there is a sort of a shift in the dynamic and the structure of where the talent is. They're still working in the industry doing the same kinds of jobs. The paycheck, the name on the paycheck is changing though as well. I'd say most of workaday geoscientists fall in this professional, scientific, and technical services space. This includes most of the folks in the consulting industry, and in most other industries as well, as far as how BLS likes to glom people together. Interestingly, though, if you look, state government, federal government remains fairly flat as far as their growth is. But again, that's still shading shading basically that we're not losing a lot. We're not adding any as well, but we still have a lot of replacement above. And local government is seeing some growth, but again, it's below the aggregate growth expected for the economy. So there's some definite shifts going on in where folks are going to be employed. So I want to talk about some of the employer feedback and observations and related pieces of data. A couple of you I know, I'm sure, have seen a few of these other talks, and I still, in the last 12 months, perhaps the best quote I heard came at the Graduate Geoscience Ed Summit, about a year ago, and the point was that the programs out there, the academic programs, are producing the best scientists folks have seen. They really are. They understand the scientific method. They think well as scientists, but the real core problem is they don't actually know how to do anything. They're lacking skills, and this is going to be sort of a mantra you're going to hear as a major frustration, that they're great thinkers, but they're not actually great doers. And some of it, I think is symptomatic, because one of the big changes that we're seeing is that the geoscience opportunities are moving downstream. The resources industry remains a major consumer of our talent, but where they need the geoscientists is no longer at the pointy tippy end of exploration. And I really have to ask the question, and as a community, are we actually communicating this to the students? Are they understanding that where those jobs are, they're going to be a bit different, and are our programs and our supports for these students better suited? Are they appropriately suited to have them in those areas? And you see some of that. So, the mining industry has lost about 100,000 geoscientists and engineering jobs, over about the last 10 years. And most of that's because of automation. Now, interestingly, most of that job loss has occurred in Asia. They basically viewed U.S. and European educated scientists and engineers have been a lot harder to replace because of automation, largely because, again, they are actually good thinkers, well-trained as scientists. So that comes home to roost. But, when we had that last big boom in both minerals and energy, earlier in the decade, a lot of commodities actually have about 400 years of reserves identified. We don't need a lot of exploration going forward. And so where they really need the geoscientists is to help in the areas of production and distribution, retirement of facilities, co-production, site design, and just like we see with the environmental industry, riding the boom of shale gas, handling all the environmental issues and all the other ancillary components that are occurring, during the actual production of resources, and a lot less of playing Indiana Jones and going out in the field, discovering new resources. And so Canvas are the various employers in different sectors, sort of getting a broad sense. There's some regional variations, and obviously specific cases, but I'd say the general feeling is in the petroleum sector, hiring is slow, but especially at the master's level, the highly skilled remain in demand, even during some of the worst times. If you came in well educated and highly skilled, you were going to find a job, and that remains the case. In the mineral sector, they feel the employment has been good. It's not really robust hiring, but at the same point, the opportunities are steady, largely because there's such a low supply of students, new graduates coming out and looking at the minerals area. But the folks that are highly skilled, maybe have some engineering design background, maybe coming out of mining engineering, are in high demand, and they're often getting multiple offers. And one of the points they said is that from a career standpoint, if they're coming in right now well skilled, the expectation is that even just graduating with a bachelor's level, they're pretty much set for their career, that their growth trajectory isn't going to necessarily require additional education. They'll be able to grow within the industry and the companies. The environmental sector, they're continuing to hire, but again, back to this whole point, they're tired of hiring students with being perspective that they may develop skills, and their experience has been, if they haven't developed much skill in college, that's a pretty good predictor they're not going to do so once employed. But they're really focused, where they're hurting is good field skills and a willingness to go in the field. This is a real problem, but also technology and technical skills, whether it's coding, programming, and drones. Having a FAA drone license is considered actually a pretty big Benny right now, as well as things like making sure you have HAZWOPER and other certifications so you can go out on drill sites and the like. So it's all those co-curricular kinds of activities that are important. And the government, again, they're really hurting for skilled technicians. In the other space, particularly at the state level, one of the things that they're pointing out is they really need graduates that are skilled with that social and science interface, dealing in the regulatory space, stakeholder space, particularly where they're being put in positions to broker between, private sector and community interests. And I'll echo that's a skill set that the minerals community also is very, very intent on continuing to develop and foster within their workforce, because of social licensing issues that pretty much dominate almost all of their operations. And so some of the skills, are obvious. They're things like coding and business skills and things like that. But one of the big predictors, and we saw this at the Graduate Education Summit, are the quantitative skills. Our students tend to lack the advanced quantitative skills, but I think one of the key questions is the why. Do they really need to know how to, go through the math class, the math department's version of these classes? The question is not so much that they have to be able to do it on paper all the time, but if they understand differential equations, then they're well equipped to start understanding things like fluid systems. Understanding and working linear algebra, they start to understand how a multivariate system actually works. Same thing with statistics as we move into more and more data analytics and machine learning. And one of the sentiments that keeps coming up too, historically we saw these advanced skills as a predictor of employees, of who was going to survive the downturns, because they were able to be lane shifted into other components of the companies. And now one of the things that we're hearing from the employers is they're cautious economically, I think, given the current environment. And it's expensive to let people go. They really don't want to hire people and then end up having to let them go. So they're also trying to hire in folks that they're seeing they have a skill set that they can envision can move around a company a little bit and then be ready to go jump right back into the geosciences when the work comes back and be able to react to that and adapt to the market. And so I think there's an increasing awareness by employers, and I think this is a good thing, that we have this bigger issue of career development for students. We need to get them to understand it. And the university sitting down here at the formal education space, and employers are pretty impressed overall, particularly with the master's and PhD graduates, about what that product, shall we say, what the education of these students that are coming out. The problem is there's now this gap of being ready for the workforce, and a lot of it are these applied skills, particularly in the private sector, more things on professionalism, and also awareness on things like licensure and regulatory awareness. And so there's this gap, and as I try to explain to students, it is unfair. Probably most everyone on this webinar today didn't really have to worry about this gap. Your formal education led you into that professional space and you were able to develop from there. Now we have these higher expectations, and this is putting pressure that the students are going to have to find those co-curricular opportunities to start building these things up. And I think the departments can hopefully start fostering opportunities in an environment where that becomes more readily available. This is where like the engineering departments do very well. Like they make sure all their students have internship opportunities, for instance, during each summer, or within projects, making sure that they're applying some of these external skills, and that some of the brown bag lunches coming in are folks from industry, or career coaches, or folks that focus on technical writing or what have you. That it's not just whatever the latest science always is that these students are engaged in. So I think that's the challenge: is how does this environment evolve to help support this new reality for particularly our undergraduate students coming out. So I want to approach a few of these macro issues that we see emerging that I think are going to impact geoscience departments. Hopefully most people are aware of them. I hope everyone here is largely aware of this enrollment cliff that is keeping so many admissions officers at the universities up at night. You look at the demographics, you look at some of the dynamics, and in some parts of the country, they're expecting sharp drops of up to 20% reduction in the total undergraduate enrollment just within the next couple of years. One example, University of Tulsa did an evaluation. They've actually already slated a whole slew of programs to be eliminated in response to this undergraduate enrollment component. It was not actually a critique of the value of those majors, but they looked and basically said there were three dogs in the fight. University of Oklahoma, Oklahoma State, University of Tulsa, and where were they sort of the weak sister, so that they could focus on their strengths to maintain their enrollments as best as possible. So that's the first to really have a structural reaction to what's expected. The other thing too that we're seeing, and if you look at the Chronicle Higher Ed and others, it's like every week yet goes another small private college out of business. But we're seeing more and more of the liberal arts colleges that are trying to pivot and remain viable, and more are launching into more applied programs. Not necessarily in the geosciences. They're doing things like actuarial science, more engineering design programs, engineering co-ops. But you do see some of the, particularly on the engineering efforts, things that are linking into the environmental engineering space and potentially could become competitors, in your recruitment for students as well. This year I think we have three new programs that geoscience programs that have popped up for the director of geoscience departments, but we aren't really capturing some of these other ones that may also, for mind share of prospective students, be in play. And I'm sure everyone has been hearing the increased questioning on the value of the bachelor's degree. We're starting to see actually some articles on that are actually trying to look at this data. There was a really interesting article that came out in the American Sociological Association's Work in Progress system, on some early research looking at this issue. And interestingly, they actually found, because as we know, men are disappearing off campus, and that the men that are still on campus are seeing a negative return as far as what they're earning and the educational appropriateness of the jobs that they're getting after graduation. So men are tending to be underemployed a lot more than women are at this point. And some of their look at it, it seemed that they were starting to see that there was better alignment, that some of the men who were probably well positioned in the past for some of the more rigorous jobs actually never went to college. They found other pathways to get to that space. But I think really profoundly, the same article really made the point. The old adage about the college education was this key thing for lifelong increased earnings and intellectual satisfaction really sits at the master's level now. It's not a bachelor's level issue, like it has traditionally been viewed. And again, that sort of echoes. There have been a few studies, Georgetown, a few others that have been showing that the college education earnings are coming in at about the same as someone with a vocational skill, professional skill, and just a high school diploma. Say an electrician or a mechanic or something like that. So that earning differential is now dropping, and so the value return that's being put forward, probably has to evolve. In the recruitment of students. I think the other thing too, this was data from a recent Geoscience Currents that AGI put out that Leila Gonzalez crafted. I think we have to ask the question: are we educating for the long game? I mean, are we preparing our students for the next step or for life? Because when you look at and what this chart shows, so these are all the folks with a terminal degree in the geosciences in the workforce. It's not recent graduates. Everyone in the workforce with a terminal geo degree. And you can see that, less than 20% at each degree level continue to actually work primarily as a geoscientist. Not necessarily totally surprising as people maybe move up in their career, but it's a bit sobering, and it sort of follows. It's not as big of an issue you see in other science and engineering spaces, particularly the masters and the bachelor's folks are moving out over into that space, and some of that, particularly master's level, I would argue probably folks that are doing more engineering-esque kind of work. Plus, there's a lot of demand over in the health sciences space. What does concern me is that 46% of the doctorates are now not doing science and engineering. Now, maybe they're CEOs. But they're not identifying within occupations that are in science and engineering. And the unknown is it's what they call a logical skip in this survey. And these are individuals who reported either that they are unemployed or no longer seeking employment, that they're out of the workforce. And so the fact that we have a third of our bachelors, terminal bachelors, not even actively in the workforce, and 21% of our doctorates is a bit of a concern. Now, some of that could be retirees, early retirees, but those are still pretty high numbers. But I think when you look and see 3% of our terminal masters are out of the workforce, again, that really reinforces the whole point that the master's is the degree of employment in the geosciences. One of the other things is the professionalization of geoscience, and I think this question is coming up more and more. Is your program licensure ready? Do you meet the educational requirements of your state licensing board? And we're seeing not just periodic pushes against licensure, but we're seeing increased pushes for adding licensing for geoscientists as a professional space. And I think one of the things, so we have a fellow here at AGI this fall that's studying licensure, and one of the things that was interesting was how common the GIT programs, state level GIT programs are. So is your degree designed in such a way so that they can take the fundamentals of geoscience exam and then be awarded a GIT and come out with the degree and a credential at the same time? The other thing too is we've identified a number of states that they don't license geologists, but they are licensing environmental professionals writ large, and something to also look at and to see how you might align. And finally, sort of on some of these core data points, the college scorecard, which is a bit of a bugaboo for a lot of folks. It's a blunt instrument to evaluate the let's say the economic efficiency of getting a degree at a specific institution, made some changes, and they announced them Wednesday, and some are good, and some I think should not so much alarm, but people need to be aware of. First thing is they updated some of their metrics, so now graduation rates are out to 8 years. To accommodate for folks that have been called up to active duty and or disruptions because of family or illnesses. I think that's fair. But I think one of their best changes is that the earnings reported are 1 year from graduation rather than the average over 10 years from graduation within state. So it's a bit more representative. But I think one of the more important things is that they are rolling out the ability to examine data by school and major. So your program could be isolated, and you could look at graduation rate, earnings, and the debt load of your graduates. Now, this data is still sparse, and as far as I can tell, reading their data dictionary, the intention seems to be as they get more years of data. Right now, they're suppressing a fair bit of it because of privacy, but as they get more data, they're probably going to go to like a 3-year moving average and be able to report out on most programs. But of those programs, and it seems like 9 graduates seems to be the threshold where they're reporting out. So in departments last year that had 9 folks graduate, the mean earnings after graduation was $35,000 a year. The maximum was, and these are departmental averages. The maximum was $67,400. And the minimum, and this is obviously a concern, that if you had 9 or more graduates, and the average your average salary after graduation was $21,900, that's a little frightening. So and then you can look at what the debt load, and the average geoscience major is walking out with $23,500 in debt from their degree program, with a range between $13,000 and $37,000, as departmental averages. Obviously, there's folks that walk out with 0 and folks that walk out with a lot more. Now, the challenge that you face as a department chair is, obviously, not only now is your institution competing with other institutions on economic efficiency. Now your program is competing with other geoscience programs at other schools, but also against other majors at your schools. So you look at physics, their earnings are $20,000 higher and their debt is lower. You look at education, their earnings are actually higher on a mean level, but their debt is actually higher, for instance. So it changes sort of the potentially the way students would look and choose majors. And using their online tool is a bit of a blunt instrument, but you can download all of their actual data that they use to present, and it's a bit better to analyze that as well. And I just want, again, it's all been about skills, and I think to understand what employers are thinking about within skills. We've seen this sort of evolution of the integration of the disciplines. I would argue that universities are still largely here. We see interdisciplinary collaborations where industry had been sitting with these integrated teams where the different disciplines are working very closely together in a work environment. But now you actually have a lot of industry moving into what are teams of integrated geoscientists rather than integrated geoscience teams. And so the real difference is, instead of having folks with engineering or a geophysics or a geology or geochemistry or landmen or whatever background, what they're really looking for is folks to develop competency and literacy across the entire spectrum, but that they're going to bring specific strengths. And these are where some of these key things of skills, measuring out skills, not just from an intellectual standpoint, but again, what the employers are saying is, what can they do? They know a lot, but they don't necessarily know how to apply it. So that's sort of wrapping up that presentation. It gives you a snapshot of where things are. There'll be a little bit more discussion of this at the Heads and Chairs meeting in San Francisco in a couple weeks. There's the URL for our workforce program. We're putting out lots of geoscience currents right now with interesting data. We just had a few about NSF funding trends that I think are rather intriguing as well. And you can always email workforce@americangeosciences.org. That will come to both myself and Leila. Happy to answer any of those questions, and happy to answer any questions that the audience might have.
All right. Thank you, Chris. That was a really interesting presentation. So for those of you who are in the audience, please feel free to type your questions and we'll have Chris answer them in the order that they come in. So Chris, here's a question that came in while you were speaking. I think it had to do with your slide related to the applied skills. Um, Someone is asking, what thoughts do you have about online training to bridge the gaps of those applied skills?
I'm sorry, could you repeat that again?
So the question was, what thoughts do you have about online training to help bridge those gaps that you were referring to,
Mm,
within related to the applied skills, professionalism and
yeah.
ethics and, the business skills?
Well, and yeah, I mean, I think the online space is critical because in most cases it's an on demand. It fits within the complex schedules folks all tend to have. And I think one of the key differences is most of the effective online programs at this point, that are professionally oriented, are focused on intentional learning, and so the takeaways for the students are usually more efficient, and because the students are coming with questions and intention to learn very very specific things, and therefore those programs are designed to be very specific and coming back. Whereas that broader intellectual exploration that you expect to have an in-person course, it has a different purpose and a different drive. So and plus your universe of providers, whether they're professional societies, there are for-profit companies that are doing it, but the other thing are the universities are providing a lot of these same kinds of opportunities as well.
Okay, so are you saying that the students are taking courses in, other areas within the university, say, for example, to learn about those business skills? Are you saying that the students are taking courses in the business school, or what exactly are you referring to?
Well, I think they exist. I know we
Okay,
haven't really measured it. I mean, one of the classics is they lost count at Stanford because they offered over 900 different certificates across the university. So how many students that are currently enrolled are leveraging those other opportunities? Hard to judge, or those outside folks. But I think the point is those opportunities exist across a myriad of spaces.
okay. So another question that came in is, any thoughts about retirees acting as online mentors to younger professionals?
I think that's can be valuable. Particularly if a young professional, emerging professional, or a student's interests align very closely to the work history of the retiree,
Mhm.
and they can be very specific. I think the challenge you face there is establishing that sort of rapport, and getting into that conversation of a lot of the more soft skill components, which is a lot easier if you're consistently sort of meeting with people individually. So I think I think there's roles for both in person and the online. I think again, the online is a little bit more intentional. The student really wants to understand what does working at the USGS, mean, or what does being in a certain occupation or certain kinds of projects. Then I think that works really well.
Mm. So, in your conversations with employers, have you heard about sort of mentoring programs within their companies? Say, someone who's working at XYZ company and they're retiring. Do these retirees sort of continue to mentor the young people that are coming into the company? Have you heard about those types of programs in for-profit or nonprofit companies?
I think the exposure I've seen on those programs have largely been at the very large companies,
Okay.
which have very structured what they view as business knowledge transfer processes, which
Mm,
really does amount to being this mentoring kind of process, and have formal programs for career development. Um, I think for a lot of other folks, it's a bit more informal, and perhaps more task based. And I think the challenge is everyone's very very busy, and mentoring is not a billable hour, unfortunately.
right.
And so you have a lot of those conflicting components where, at least in the larger companies, you do, and it seems that places, the Exxons and the Schlumbergers and the large mining companies, and I can't really speak for some of the larger environmental and engineering firms, but I would expect it would be similar. They do have better capacity to support that formally.
Okay, thank you. So another question that's popped in is, are there any updates on the trends with women specifically in the geosciences?
Yeah, we remain the gender issue. We remain the second best in STEM. Biology is actually overrepresented in the mid 70% uh, level for women. Geosciences, we continue to bop around somewhere in the high 40% in our degrees granted, a little bit higher in our enrollments on average. And it's been pretty rock steady for about 10 years, particularly if we take out, there was a little surge about 4 or 5 years ago. And there was like a cohort of just men coming in that seemed to be coming in because they wanted to get out into the out into the rigs for using geology as a way to get out into the rigs in the shale fields. After that sort of surge went through, it went back to the old patterns. Um, so it's been fairly steady. It's been interesting that it has remained steady all the while. We see the percentage of women on campus continue to grow steadily. I think it is heartening that we have remained steady because there are other fields, both physics and computer science especially, that have seen a collapse in the percentage of women in their programs.
Mm. Okay, thanks. So Leela, if you're still online, if there's a geoscience currents related to this, the demographics, if you could post a link, that would be lovely. Um,
Absolutely.
Thanks. So here's another question for you, Chris. Is demand for mined materials and energy increasing with an increasing population? If yes, why is employment not responding?
Yeah, no, I mean the demand for material it continues to grow. I think one of the things, and it's in the vernacular, is moving away from the idea of mines and mine material, and it's really raw materials writ large. In Europe, they're doing a lot of work looking at both secondary recovery from mines, but also recycling, and as they call urban ore fields, and things like that to mine. The efficiencies that you now see in the mining industry are pretty staggering, and that's actually one of the key things that's driving the steady employment and not the growth. Is technology has accommodated for a lot of what's needed. Often now, it's one geoscientist, for multiple sites rather than multiple geoscientists for a single site. Down in Australia, they have actually a couple operations where everything is remote. All the operations and monitoring is done. I think at a control center in Melbourne. The actual operation is out Western Australia. They're remotely controlled vehicles, and really they just fly in mechanics periodically to try to keep the stuff going. So there's a lot in that space, but part of it too is there's also increasing need for advanced chemistry and other issues in that raw material space, and I think we're missing opportunities with our students that are being trained in geochemistry to sort of broaden their horizons as well, to things that maybe historically have been viewed as metallurgic and material science kinds of spaces, because the problem domain is pretty fluid between them.
Hmm. Interesting. So another attendee asks about your thoughts on alternative experiences to traditional field camp, such as training students for the workforce. Say some field work, but maybe enhancing other skills such as coding versus your traditional 6 weeks of, doing mapping projects out west.
I
Have you
think
seen any such examples, or what are your thoughts?
I think we see a lot that we see the field experiences delivered in a lot of different mechanisms. There are some that do like 1 and 2 week courses, both through the course of semesters and like winter breaks and things like that, and try to string it together. Yeah, they're traditional field camps. I have not seen groups that have sort of substituted like a coding course for that field camp experience. I think the question that that the community needs to debate on it is, I think one of the key aha moments that a lot of students get out of field camp is it's when they suddenly can synthesize it all, because it's in that context. So if there are ways that we can deliver that area and get them really thinking as a geoscientist in an integrated fashion, then I think there's lots of options. But I think when we talk to employers, the environmental folks and the mining folks, they really want people that have that field experience because they need the field skills. But everyone goes, we really like them to do it because they come in with a better integrated view of the science. So if there's other ways to do that, I think employers would be happy to entertain it. I just don't know, where that space really lies.
So another attendee asks, did you see anything in the data about the growth of jobs for geoscientists in the renewable energy sector?
That's a hard one to delve out completely. But if you look at one of the spaces where I think we see a bunch of that is actually as in the geographer space, which happened to be growing right pegged on to the economic growth of of the country. I think it was at like 5.9%, if I recall. Because a lot of that in the classifications that the Department of Labor uses, it seems geomorphology, if it isn't directly hazards related, seems to be gets lumped into those renewable spaces where you get a lot. It's a lot about the siting, whether it's wind farms or solar or similar. In sort of the higher tech stuff, it's too buried in the data right now to find whether it's in biofuels, carbon capture, you name all those other spaces. The accounting for it hasn't really caught up to actually capture that appropriately.
Interesting. So another attendee asks if you have any thoughts about some of the trends that we're seeing in the geosciences about minority participation, be it whether, in our departments or even graduating from our departments. Any thoughts on what those trends are trying to say?
Yeah, we're really still struggling as a community to engage the best and brightest because we're not engaging the whole population. The those trends. One of the complications, and I think folks need to understand this when they look at any of the diversity data. When in 2010 the government allowed multiracial to be applied, it stuff got really murky. People weren't binning themselves, and so at what point do you call someone something based on how they did it and what constitutes diversity? It sounds like a step around, but it has legitimately complicated the data. Um, we keep bouncing around at about the 8% level for enrollments. I'm more concerned, and we don't see that in the graduation rate. So what we seem to be able, we have a mode to get a certain population to engage with geoscience. We're not doing a great job getting them out the backside with a degree and into the profession. And I think one of my concerns when we've looked at employment levels in the economy, and then we have a couple currents with this in it, there are some pretty sharp responses that when the economy drops, the percentage of underrepresented minorities working as geoscientists drop precipitously. And that really worries me because that says that they're in more marginalized jobs than the bulk of the geoscience population. So there's a lot of work to do in that space, and the ends are small, so the reporting is very challenging. But to me, it's the kind of thing that we need to find ways to launch some longitudinal studies to understand where those inflection points are, and to try to identify where the shortcomings happen to be. But I can tell you our current recruitment efforts haven't really moved the needle much at all. And in some ways, we should probably be investing more in getting folks all the way through and in retention. So at least the recruitment we do have, at least is a positive experience at the same rate as all the other students.
Right. Good. That's a good observation, and I think something for the community to think about as department chairs are thinking about the new class of students that have come in this year and will be coming in future years. So there are some questions from the same gentleman asking about So asking if we need more people with training in automation and the geosciences. No, it's a question to you.
Yeah, no, I mean, I think
Mm-hmm.
the answer is absolutely. Um, the opportunity for someone to land employment has, I think, more to do with having multiple domain skills.
Mm-hmm.
And so if you have a student coming out, with the geoscience disciplinary background, and whether it's on electrical engineering, automation, coding, these are difference makers, and they are measurable skills. And this is the kind of stuff the employers are, really looking at. Um, it has, I've noticed, it's been a career accelerator for some individuals. I actually had an intern who, was had a geology degree and was working on his drone license, and now he is the head of the drone program for, law enforcement and Department of Natural Resources in Maine, apparently. Just after a couple years, and applying a lot of the remote sensing and geomorphology and all the other kinds of domain components as well into that space. So, yeah, there's a lot to be said for that. And I think it's also, to recognize that the technology is just a technology, and to have individuals that understand how the domain science plugs into it, that's the golden key that everyone needs. You can run a neural network and plow data into it and have results come out, but if you can't apply the science and understand what that's really saying, uh, then it's a garbage in, garbage out kind of problem.
Mm, right. So let's take this one last question before we run out of time. So the same person is asking, so we need to be thinking more globally to fill the gaps, in our workforce. What thoughts do you have on that?
As far as the global population, um, as far as for talent recruitment.
Yes, I believe that's how I would interpret it for
Okay.
talent.
Yeah, I mean, I think one way to look at it. So we're part of a project called Intermin, which is this trying to develop this network of raw material training centers, and so, like, in that space, one of the things that is recognized is that there is no one place that an individual at the post baccalaureate level can go to really actually get a well-rounded background as a professional in the raw material area.
Mm,
There are lots of programs out there that have little spikes of that they can teach, and so I think one has to look around and realize that you have a couple issues. You have levels of capacity by universities and training companies. But I think you also have the other side that, traditionally the schools in places like Chile and Germany, for instance, the UK, have produced, Australia have produced very, very strong geoscientists historically. Canada, the Canadian undergraduates that come out are just unbelievably well qualified. But now we've seen great improvements in the quality of the students that are coming out of, say, China, Indonesia, places like that. So a lot of places that were sort of, I would, hate calling it, but sort of second tier, or weren't quite up to the snuff of the Western universities. They really have gotten there, and so the students are going to be competing on a broader space. If they're interested in resources, most of the resource companies, whether it's a Schlumberger or some of the mining companies, groups like that, they're very sensitive and they like to hire in proportion to where their operations are. So if 15% of their operations is in the United States, 15% of their new hires will be in the United States. So in a lot of cases, these students are going to be competing against a global pool. So got to be the best of the best.
mm. Great. Thank you for that answer. So this concludes our webinar and discussion for today. If you have missed any of the previous webinars from this series, please go to the AGI webinars webpage where you can find recordings of previous webinars. And with that, I wanted to say thank you to everybody and have a great weekend.